Hi everyone, my name's Alexis Smith, and I manage our Developer Partner Program here at DFINITY. I'm really excited for the next panel today, which is focused on building solutions on the internet computer. This will be a more technical panel, and we have 3 developers joining us today. Enzo Haussecker, who's a senior software developer at DFINITY, and we also are joined by Rick Porter and David Phan, 2 veterans in the blockchain space and software developers at the ORIGYN Project, which is focused on building solutions for the internet computer. So today we're going to be focusing on what it's like to be a developer for the internet computer. So we'll be hearing from Enzo, Rick, and David about some of the projects that they've worked on, as well as how you get started with building canisters and building applications and enterprise solutions for the internet computer. We'll also focus a bit on how the architecture of applications is turned on its head with the internet computer, and how the simplicity of building apps is really a major benefit for developers. So we're really excited to dig in with you today, and we hope that this conversation will be enlightening to developers who are just getting started and they want to know what's possible with the internet computer. So to start us off today, Enzo, Dom spoke earlier today about how deploying software to the internet computer is super easy. So developers can basically just write their code and directly deploy it. Is that really the case? Is it really that easy?
Yeah, I think that's a totally fair characterization. One of the things that DFINITY makes it really easy for is for you as a developer to really focus on where you add value, which is typically in defining your business logic. Developers, at least in my experience, don't want to deal with replication and failover and database administration and the likes, but really just to focus on where they feel like they're making the most contribution. So one of the things I think that's really cool is that developers can really focus on where it is that they're adding value. Developers don't really add value through replication and failover and database administration and all these and the likes. This is for a long time, this has just been things that we have had to deal with in software development. And one of the things that a lot of developers are looking for is a platform where they get all this stuff for free and they can really focus on their business logic. Defining that business logic in code, being able to compile that code down to WebAssembly and deploy that WebAssembly binary on the IC platform.
That's great. Thanks so much, Enzo. And Rick, if we could switch over to you for a moment, you have a ton of experience developing enterprise platforms, consumer products, both in the centralized and decentralized space. And I would love for you to share a little bit about what kind of existing computer science paradigms or principles does the internet computer feel like? So as a developer kind of entering in for the first time, what would you compare this experience to?
Yeah, it feels a lot like microservice architecture, which pretty sure it is. And you have that ability to actually spin up all these independent canisters or services that have their own kind of independent function that they must take care of. And you can string them all together through different types of inter-canister communication. But you can also do a monolith. You can also do monolithic architecture with inside of DFINITY. You can take an entire application and put it in one single canister and completely manage it through that process, or you can start breaking it down into its individual components.
Great. And actually, David, I would love to switch over to you, building on what Rick just said. So you have some experience building decentralized applications, and one of the more challenging aspects of this is actually building a front end and a great user experience. I'm wondering if you could walk us through sort of the past experience of building front ends for decentralized applications and how this new canister architecture in the internet computer has enabled you to build better front ends.
So in terms of front-end development, you usually develop it in JavaScript. So you will call your SLM provider using Web3.js. So for example, I was using Guess and Infura. And to host your dApps, you were using maybe a traditional hosting or maybe IPFS or Swarm. And now in this new paradigm on DFINITY, we got the DFINITY starter package that is based on Webpack, and you can develop your front end using any JavaScript or TypeScript framework. So you can use Vue or React. So I personally already developed some DFINITY dApps using Vue and Vuetify. And in order to call the canisters, basically you just import the canister module that is generated by the Candid compiler, and you just call the functions of your canister with a similar syntax to Motoko. Once this canister code is deployed on the internet computer, you got the front-end code that is bundled, and it's hosted on this internet computer too. So I found the overall developer experience slightly better than using this Ethereum Web3.js. Yeah.
That's great. Thanks, David. Switching back to you for a second, Rick. I know that you and I have had some conversations around how the internet computer really takes this 3-tier traditional architecture and kind of turns it on its head. And that, as a software developer, you've been really excited to see sort of how that traditional 3 tiers of kind of UX, client-facing layer, the database layer, and the business logic layer are all sort of changed in this new paradigm. I wanted to see if you could maybe share an example with us from your work with the ORIGYN Project that reflects sort of what this new architecture looks like.
Yeah, for sure. So ORIGYN is kind of acting as an ERP for watches, right? Where you have all this data, we have all this watches stored inside of the ORIGYN, these ORIGYN canisters. And you have this traditional, you could think about it as a traditional database where you have your schema, and the watches themselves follow this kind of paradigm where they're all stored within inside of this schema and following all the different standards where they have all their different relationships. The company that the watch belongs to, the winding mechanism that the watch has, and as you hear these different components, you can start visualizing the schema itself for the project. And we have this data representation within inside of the ORIGYN canister itself, as described, so that when data is actually coming in, it is actually fit within, it's transformed to fit within inside of this data model. But if you took this data model out of DFINITY and you just wrote it down, it would, in some sort of pseudocode, it would appear to be just like any other traditional data system that you would see. So this is kind of the database of the system. It's stored within inside of the canister, and there's no need to have some sort of like ORM in place, object relational mapping, or any type of communication to a database, because of the orthogonal persistence itself. All the information forever exists within inside of this canister. So you're really just creating CRUD for the canisters themselves: create, read, updates, deletes. And obviously you'll have a lot of different types of sorting and listing functions, or some sort of map reduce that is returned to the front end. But abstractly, you just have that CRUD, and all the API itself, when communicating with the ORIGYN canister, takes in each one of these requests and each one of these actions, and your code within inside of DFINITY handles it. And it's updating objects in memory. It's not, creating a transaction for a database, creating your SQL statement and performing an insert. By updating the object within memory, it's persisted within inside of the canister at the end of the transaction. And so when working with front-end technology like what David described, you have your front end, which we use Vue.js, that just calls these endpoints that are exposed by the actor within inside of the DFINITY canister to perform these very specific types of actions.
So we heard how the internet computer can really simplify the architecture of applications. We also heard from David on how the development experience is much easier for front end. But one of the major challenges still facing us in the decentralized space is this issue of scalability. And we saw a preview today of the app that you'll see more of later today, CanCan, which is a decentralized, scalable video sharing app. And we're lucky to have Enzo with us today, who is one of the key developers behind CanCan. Enzo, I was hoping you could share with us a few of the scalability solutions that were considered for CanCan, and how these scalable applications are really made possible on the internet computer.
Great question. So I would say scalability is really multifaceted, and perhaps some of the most important points to focus on really there are really thinking about scalability from the perspective of the end user. and what are the specific use cases that they have that they're able to sort of get for free from the platform. So when I think about these types of use cases, I mostly think about scalability just in terms of storage, and I'm happy to speak to other points as well. But in the context of storage, an individual canister itself is just a WebAssembly module that has sort of this, this linear memory section associated with it, which can grow up to 4 gigabytes in size. And then beyond that, you do actually need to think about distributing your data across possibly multiple canisters. And that's actually not a limitation that's comes from us. That's a limitation that comes from the WebAssembly specification itself. So even if you're whether you're running WebAssembly on the IC platform or whether you're running WebAssembly in the browser, you do have that same limitation. So in that context, the canisters themselves, you have the ability to sort of start off small, maybe a canister. I think the initial size of that memory is something like 64 kilobytes, and then you can always grow that to some offset of the WebAssembly page size, which is also 64 kilobytes, but never really exceeding more than 4 gigabytes, with that limitation there being the upper bound. So there's a couple of different strategies that you could take to distribute data across multiple canisters. One of the things that I worked on for a video streaming application was just implementing a distributed hash table. So that is taking a hash table and really splitting the contents of the data across multiple nodes or canisters in this case. And we did this just because DHTs have been around for a long time. There are several popular implementations to choose from: Chord, Kademlia, Pastry, Tapestry. And a lot of these implementations, they do have some common themes associated with them. There's usually some notion of key space partitioning, which splits ownership of data amongst participating nodes or canisters, again in this case. And then also some notion of an overlay network, which allows nodes to find the owner of a given key. So an important thing to note there, though, is that the internet computer doesn't actually have network interfaces associated with it. It has rather canister interfaces. So any notion of an overlay network must be a virtual construct, of course. But the WebAssembly-based virtual machine that's provided by the IC platform implements a set of host functions that allow canisters to sort of call one another. So you can think about these types of overlay networks that you would typically have running for over TCP/IP for a more traditional DHT, just operating via canister calls in DFINITY. And so with that, basically what we were able to do was take video files, chop them up into sort of video fragment files and together with a manifest file, and just take all that data and write it into this key value store that was distributed across multiple canisters, and then be able to serve that data on demand to users who are consuming content. So the use case there is that if a user wants to sort of stream a video, that they're able to sort of load a web interface, and sort of as they're consuming content, be able to fetch in these video fragment files on demand and have them display and render in their browser. And to do that in a way that this data can sort of persist with this type of backend here, and the end developer not really having to think too hard about building the application at all. In fact, one of the really cool things I'd say about this specific application that I got to work on was really just the fact that the way in which the front end and back end were able to be separated were really able to be just treated as two entirely distinct entities.
Yeah, and on that point, Enzo, around this ability to kind of swap in another back-end solution, we ultimately ended up using a scalability solution that we came up with internally called BigMap. I'm wondering if you can share a little bit about BigMap and how it works. And we'll obviously dig into the details later today in the technical demo of CanCan, but maybe you could share a little bit about how that solution is a little different from your DHT solution.
BigMap actually is an implementation of a distributed hash table. So it is a lot of the same ideas there. I think that there are some simplifications that were made to the code that we like, things that we got for free from the platform. For example, typically with a lot of DHTs, you can set a replication factor to be like 2 or 3 depending on how many times you want to maintain copies of a given file. Like in the case of DFINITY, you get replication and failover for free, so we only need to maintain 1 copy. Like that's a simplification. And other similar types of things where really, I guess, where would I add context there too? Like in networking, for example. In DFINITY, there are no network interfaces associated with canisters. Canisters have canister interfaces, and the ability to call one canister from another is something that you get, is a feature that's provided to you from the system. So, for example, you don't need to you don't need to think about replication. You don't need to think about networking. And actually, for an implementation of a DHT in like some other more traditional context, dealing with all that stuff is like, it amounts to a lot of code, right? So for the end developer, it's less code that you have to maintain. So I wouldn't say it's very different per se, but I would say that you get a lot of simplifications and you get a lot of that for free, given the very specific properties that are provided by the platform. Maybe actually on the topic of scalability, I'd actually really like to maybe hear a little bit more from Rick, who's working on a current application right now in which you're actually, as I understand it, storing images of these watches. Is that right? And how you're able to actually kind of deal with some of the scalability aspects there. Have you tried plugging into something like Motoko BigMap or some of the other DHT implementations out there, be them in Motoko based or Rust based?
Yeah, so we're definitely going down that route of trying to figure out how do we actually store the models within DFINITY, and the BigMap is going to be one of the different ways that we're able to do this. We have thousands and thousands of images associated with the content that we're going to be putting on top of DFINITY, along with trained models that have been trained offline. But we're going to try to figure out how do we put this trained model within inside of DFINITY and possibly use Rust to do the lookups against these models if we can store those algorithms within inside of DFINITY itself.
So until everything is built on the internet computer, which is what we all hope for, there's probably going to be some need to build integrations and connections into existing systems that are kind of external to the internet computer. And David, you have a really cool example that I was hoping you could walk us through today around the ICP mailer that you've built. Can you talk a little bit about sort of what it was like to build those integrations into an existing system?
Yeah, so basically right now we have a gap between the internet computer and the traditional web. Basically, I have an example. How can I send an email from a canister, or how can I fetch some data from an API? Like I want to fetch the delivery status of a package on DHL. How can I do that from the internet computer? So as these services don't exist in DFINITY, we built a platform that fills this gap. So it connects the internet computer to some legacy systems. Basically, we created a proof of concept that allows Motoko developers to send custom messages to a 5.4Q canister. These messages are pushed to some legacy systems that we've built and via some external workers. So this platform is extensible. It allows you to trigger some calls back to DFINITY. The 3 main steps for the development of this platform were to develop this generic queue in Motoko. I imported using Vessel, a package manager for Motoko that I advise you to check out. And basically this queue has some restriction. Only some different canister ID or public keys can add some tasks, so there is some sort of authentication. The second step was to develop a web interface. So the second step was to develop a web interface that will deploy 1 queue canister per application. And finally, I think we developed a backend worker that will periodically fetch this queue canister and then process each message of this queue.
So Rick, you have experience along with David in building enterprise POCs in the decentralized space. And I know something we've talked about recently is how quickly you're able to kind of spin up prototypes and platforms for enterprise solutions. I'm wondering if you can just talk about just that process and sort of the time that's been cut down in the overall development process and getting some of these solutions in front of clients quicker.
Yeah, so we have a background in pretty much building proof of concepts with inside of the decentralized space. And there's all these different types of layers that you always have to put together to make sure this is a successful project. Typically, you have some sort of front end communicating to a deployed back end. And when we built things with previous decentralized technology, it was at times it could have been a pretty heavy lift. You've got to host the protocol, and then you have to have some sort of file storage, and you got to put it on a server. And then most likely you had some sort of man in the middle, some sort of database that was actually housing the data and maybe even a relay that would communicate to the decentralized technology, some sort of service bus in the middle. And building on a lot of what we've been talking about, all these things are kind of out of the box with DFINITY. DFINITY is the business layer. All the business logic sits inside with it, and it has the data layer. So all your data is stored and persisted within inside of DFINITY, making the actual process of building the POC extremely easy. We basically need for these POCs is to store information, right? We need to be able to store, retrieve, and perform some sort of business logic. So all that exists within inside of DFINITY, and it's just designing these modules within inside of Motoko itself and testing them and creating your unit test and throwing it inside of the canister and then building your front end on top of it. And what is nice about the way that the DFINITY project is set up is right now, if we want some sort of front end, we want a traditional 3-tier architecture application, you just generate the project and you've already gotten like 20 or 30% of it done. It's all about designing the data types and creating the interfaces, typically some sort of simple CRUD stuff for a POC, and then building out that front end. And so it's super fast. It's pretty easy once you get over the hump of learning the language. But once you've put everything up and it's up and running, it's very easy to see it.
Great. Well, to finish us off today, I would love to do a bit of a speed round with you all. Some of the developers and folks joining us today may not have experience with building for the internet computer or the Motoko language. And I know at some point you were all new developers to the internet computer as well. So I'd love to just go around and share a few thoughts with the developers out there on how you got started and some of the tips that you would pass along.
I'll take that first because, gosh, there are so many resources out there for newbies. One of the best resources for me personally has been the forum.dfinity.org. There's a pretty active community of developers, people going. I think a lot of the content there is very much Motoko focused, but also people developing applications in other languages that are compiling down to WebAssembly. There's that. There are also the GitHubs of a lot of the core devs. A lot of them have got projects in Motoko and other and the likes that compiling down to WebAssembly and deploying to the IC platform. I personally have, I think, at least over a dozen projects, and some of these are pretty, and they range in complexity too, from something simple like implementing SHA-256 in Motoko to implementing a QR code generator to implementing a distributed hash table. There's a lot of examples there, and certainly for a lot of my colleagues as well. In addition to that, I would also say that there has also been content produced in the form of blog posts, and I wrote a blog post about this QR code generator in Motoko. So this was my first microservice on DFINITY. Actually, it's like a very self-contained microservice. I was like, I just want to deploy a microservice where I give it a string and then it sends me back QR code. Like, that's it. Well, it's the simplest thing I could do. I wrote a blog post about that. Then also, there are these more complex applications that maybe aren't good for just starting out, but if you sort of evolve what you're working on and start doing something slightly more complex, there are apps out there like Linked Up and CanCan, sort of these open internet services that people are working on these days. And I think you can sort of start with some of those small pieces and then see how they fit together. And you go from maybe a very simple example, which is, I don't know, maybe like deploying a counter or your hello world, to doing something much more involved and elaborate that has a user interface where you've got a much larger backend split across multiple canisters. Maybe you're streaming video data, pulling in images, and really actually just see just how little code you actually really need to maintain as an end developer in order to get something really cool off the ground.
That's great, Enzo. Thanks so much. Rick, David, any thoughts to share?
Definitely all of what Enzo was saying those are great resources. The DFINITY forums are amazing. The community there are very responsive. They're very helpful. Everyone's very straightforward with how they're going to help, and they're willing to dig into the problem with you, which I find very helpful. All the core devs, yes, even Enzo, going through Enzo's repositories have helped us quite a bit get through some basic problems of how do we even create these objects or data structures or functions. And actually the standard library itself is another big resource. I feel like most of the problems we wanted to solve, or we wanted to figure out how it was done to standard library, had some form of high level answer for us that we could actually dig through and actually an answer.
So basically, read all the example on GitHub. The Linked Up project was the first one that I looked at. After that, there is the content from Enzo. He's doing like a podcast or a video, which is named Hack on the Internet Computer. It's on YouTube. And the forums were really useful.
So one last round robin before we close things out for the day. I would love to hear from each of you. What would you love to see built on the Internet Computer?
A Shopify built on top of DFINITY would be very interesting. The ability for anybody to kind of go in there and list some sort of goods for sale, even if it's digital or tangible or whatever, and build a little website around their store and then have all the bells and whistles that DFINITY offers, as well as like other people being able to develop widgets or utilities for the Shopify application. I think it'd be very interesting.
I got an idea around maybe a decentralized Uber on DFINITY. So usually, like right now, we have like a big companies that get all the fees, and maybe if there is something like Uber on that is open, could be really interesting.
Well, it's funny that you asked that question because I just got out of a hackathon actually that lasted for 2 days. So this was mostly people working in Motoko, but other languages that compiled down to WebAssembly and deployed on the platform too. I believe it was 12 or 13 teams. Working on some really cool stuff. That includes something like an open Zoom, which allowed people to do sort of this type of conferencing with video communication. There was another app called Bookworm, which was kind of like an open publishing company, and then what was the other one? An application called Shield, which allowed people to link up with other people in their community to sort of get some help with this whole coronavirus thing that's going on. So getting your groceries, filling prescriptions and the likes. And so it's interesting. A lot of different people, a lot of different ideas, ranging in complexity from being very simple to much more involved. But that's really one of the cool things about the IC platform is that it's not like the sort of more traditional smart contracts that I think a lot of people who were in this space before were accustomed to using. You really can build more full-scale style applications that can service hundreds of thousands of users.
Well, I'm really excited hearing about all of these awesome ideas. And the great news is that apps like Linked Up and CanCan, which have been very helpful for Enzo, David, and Rick in getting started, will all be open source, as well as many of the hackathon projects that Enzo just talked about as well. So we're hoping that kind of all the content that we talked about today in the panel, as well as these examples, will inspire you and get you started on your journey as you build on the internet computer. So thanks so much, everyone, for joining us. A special thank you to Enzo, David, and Rick for your time today, for sharing your valuable insights. And I know I'm excited, and hopefully the rest of folks are excited to get building on the internet computer. So thanks again.